All right, hello everybody, and welcome to this talk about plugin architectures with Layrry and the Java module system. And I'm really excited about being for the first time at JFall, and also it's the first joint talk with Andres. Actually, we have met a couple of times at different conferences. Andres had spoken about Layrry actually, and now it's the first time we get to talk about this together, and I'm really excited about it. We are going to talk about just briefly about JPMS. So the idea is you got some rough idea and understanding about the module system. We will tell about some shortcomings we perceive and how we actually think Layrry can help with addressing those. And we will do some awesome demo. Andres has prepared an awesome demo with JavaFX. And well, we will be live there during the day, of course, for any questions. And we hopefully will have a lively discussion with you all. Just a few words about myself. I work as a software engineer at Red Hat, and I'm mostly focusing on a project called Debezium. Before that, I used to work in Hibernate. I've been working as the spec lead for Bean Validation 2.0, and there's quite a few open source projects I'm involved with, and Layrry being one of them. And if you're curious what I'm up to, then I would suggest you follow me on Twitter. And then, well, Andres, take it away.
So my name is Almiray. I'm a senior principal product manager at Oracle, although I refer to myself as a seasoned sourcer because I love to work with open source and pretty much do source code all day long. I'm an Apache Groovy PMC, I'm a former Java champion, and I just love open source. And when I heard about the Layrry project that Gunnar started in March of this year, I just was blown away. Now you'll see in a moment, hopefully you can also appreciate why I believe that Layrry is such a groundbreaking library and groundbreaking tool. So with this, you might be aware of the JPMS. I mean, it's something that came out in Java 9. It stands for the Java Platform Module System, also known as Project Jigsaw. It took like 7 years for this to finally come out. And it was originally designed to deconstruct the whole JVM, which is a big monolith, to make sure that it was much easier to have all the different interactions with the APIs inside the JVM. And because of how the work was going in the JVM, the architects decided that it might be a good idea to have the same facilities in user space, in application space, so that we as developers will have additional tools to design our applications so that we have better encapsulation and better design foundations. And this was the whole idea. But, however, some things that have happened is that when you ask developers if they have actually jumped into JPMS and embracing the module system, there you often find things like, well, JPMS only allows you for one version of the module, which is true. The spec doesn't say anything about versioning. JPMS doesn't allow to add modules at runtime, which is also true. You have to compose your modules at pretty much when you're building your application, where you're building an image. It allows you to have additional capabilities as creating a JLink image. But once you do, then it's pretty much set in stone. You have to modularize all your dependencies in order to reap all the benefits of the module system. That's also something that we hear constantly. It's so hard to map a dependency coordinates to module dependencies because it happens. The specification doesn't say anything about how a module should be deployed. Right now, it's just a mere happenstance, a coincidence. That's a one-jar mapping to a single module, but this could change in the future. And that lastly, well, there's always this constraint of they are non-exported packages, and then JPMS also has this constraint that split packages should not happen anymore. We used to have, in the past, a package name across different jars. Well, this is no longer available in JPMS. So what can we do about this? Is it something that can solve these problems? Well, this is exactly where Layrry comes in. And it does it using a specific feature that is found in the same APIs provided by the JDK, which is called a module layer. And it's exactly this feature that Gunnar found, and he made use when he created Layrry. And I believe now, Gunnar, it will be a good moment for you to explain more about what is the module layer.
Right, and well, it's always a good idea to look into the Java doc, right? And so just, I mean, you can read it out, you can read it yourself, but quickly to read it out. A layer is created from a graph of modules in a configuration and a function that maps each module to a class loader. Creating a layer informs the Java virtual machine about the classes that may be loaded from the modules so that the Java virtual machine knows which module that each class is a member of. So that's a mouthful. So what does it really mean? Essentially, I would consider it as some sort of a class loader toolkit. So it allows you to, or gives you fine-grained control over the class loader hierarchy in your application, which modules should be loaded by which class loader. And those layers, they can also be added and removed at runtime dynamically. So this also touches on one of the things Andrews mentioned. With the regular module path option, you couldn't do this, whereas layers enable this, and we will see how you could actually do this. And now there's this API in the Java, in the JDK, and this is how you would work with the layers API. So there's this notion of a boot layer, which essentially contains all the modules which are present on the module class, on the module path. And then essentially you can create what's called a module layer, and this would be based, or it would sit on top of this boot layer. And in this additional module layer, you work with what's called a module finder, and this module finder essentially takes a list of paths, and those paths, they are directories or jars themselves, which essentially describe the modules you would like to add to this layer. And then there's another component coming into the picture, which is called the configuration. In the configuration, essentially you combine this finder, which you have created before, and then you say, okay, which modules actually should be obtained from there. And finally, you can cast it into a new layer, which in this case would be derived from the boot layer. And here you have different options about the class loading configuration. So you could have one loader per module. In this case, I'm just using a single class loader for all the modules from this layer. And this is, well, it gives you the flexibility we are after, but you already see it's quite complex, quite cumbersome to use. You need to think about how do actually those modules get to those directories so you can load them from those paths. And it's, I would say, very flexible, but also a bit, you know, with the flexibility, it is also often tricky to use. And this is essentially where Layrry comes in, because it really sits on top of this layer API coming from the JDK, and it aims to make some things a bit simpler for you as a user. And really, the motivation which made me look into this was this very common problem we have so often, that we have in our applications, we have complex dependency graphs, and typically there can be a situation where you have transitive dependencies and in different versions, and they kind of collide. So if you look at this graph here, I have my app module. This depends on two other modules, foo and bar, and those in turn, they depend on this example greeter module. And if you look closely, it's in different versions. So foo depends on greeter 1, bar depends on greeter 2, and maybe there's an API incompatibility between those two greeter versions. And now with a single class path, or also the plain module path, you couldn't really do this. You would run into you know, exceptions, because in one point the class definitions just would collide. So this one, it was really the motivation for me to look into layers and come up with Layrry and try to provide the simplification based on top of that. And now this is how it would look like in Layrry. So it provides you different ways for assembling such a module and layer graph, and one of them is just this Fluent API. And this really describes the same layer hierarchy which we have seen before, so with our app and foo and bar modules and so on. And well, it's, I would say, quite intuitively, quite intuitive to see how it works. So you just define a layer. So I first define my log layer. I have my Apache logging modules there, and log4j modules there. Then I have two more layers, foo and bar, which have the log layer as their parent, and which add more modules, amongst them those greeter modules in different versions. And finally, I have this app module, which has the foo and the bar layers as its parent, and adds an application module. And now this will be able to run those two different greeter modules in their different versions, because they are isolated by class loaders in those different layers. So that's the one way how you could actually run this. And what I should say really is, to be very clear, that, you know, it's a little bit like this iceberg. So Layrry is just a very thin layer on top of the JPMS. 90% or 95% of the complexity, they are, you know, already solved by JPMS itself. And really there is just, I would say, some, you know, convenience layer. It does some things like adding this notion of plugins, which we'll touch on, and adding a notion of provisioning modules, which we will see also. But really the big part on the water, which we don't see here, that's the JPMS itself. So I think, Andres, you would like to talk about the launchers, right?
Right, because this, well, this example that you're seeing here is exactly the same as Gunnar just displayed, but instead of using the programmatic API, instead of using code to configure your application, here we have an external file, which is in this case using the YAML format. And we can, if you can appreciate here, we can define the layers using the same names with the same structure and the same artifacts IDs and groups and everything else. And one important thing is that right now, Layrry will resolve your dependencies using the, I think it's Maven Shrink Wrap. That means I will talk to Maven Central and any other repository that you may have already configured your settings XML file for the time being. Now, once you have a file, a configuration file like this, you can use the Layrry launcher all jar. Right now, the latest version is 1.0 snapshot. We'll be ready soon to make it a one release. And well, you can build it yourself. Once you have the launcher, you can pass this layers config command option and pass in the configuration file, and that will allow you to bootstrap the application. But if YAML were not to be the case, then we have some options. And this the other parameterization option is that here I have another example. This is actually the JavaFX example that we're going to see today in the demo. And you can see that it has the definitions for the group ID, artifact IDs, and whatnot. But in the case of JavaFX, the R dependencies are very specific to the platform that you're using. There's Windows, Linux, and Mac. And we will have to either have separate configuration files per platform, which will probably be a little bit troublesome for some people if they choose the wrong configuration file, or better yet would be if Layrry were to detect the OS and inject OS-specific values to our configuration. That's exactly what's happening here. We have a built-in template support based on Mustache. You see there are some placeholders here for the detected JavaFX name. This will be Mac or Wind or Linux. We also have the JavaFX versions and other versions that come in from a separate configuration file. It's just a properties file that can contain any key values. We can instruct the Layrry launcher with those two input files, the layers file on one side, which could be YAML or TOML, and a properties file. And the Layrry launcher will mix in the two things while doing the bootup process and launch your application. The other way that you can currently have to launch a Layrry application is to use jbang. So jbang started as a quick way to have dependencies on top of what the JEP 330 is, which is single source file launch, but it has evolved much more than that, because it also allows you to run Java 8 if you want to. Of course, if you want to take advantage of Layrry, the recommended JDK version is 11. And take it to the latest version. So if you do not want to use the Layrry launcher directly, then if you have jbang enabled, then you can launch it to this catalog called the Layrry at the Moditech GitHub organization. You can also have internal catalogs if you want to point out to different versions. But here is just another way for you to bootstrap an application if you don't have access to the Layrry launcher.
Right. And I mean, this is really cool, right? So I think you can install jbang via things like SDKman, so it's really easy to get hold of jbang. And then you just point it to your layers configuration, and it will take care of everything else from there, right? So it will download the modules or jars. It could be like, you know, just regular jars which are encapsulated in a layer. It will download them. It will bootstrap the application for you, and this is really very, very easy, I would say, getting started with such a
correct. and we currently offering you these two options, and there may be some additional options in the future just to make sure that you can bootstrap Layrry in many different ways. And now, the plugin architectures, this is the feature that when I saw the first blog post by Gunnar, I said, this is it. I was really reticent to jump into JPMS, but being able to have dynamic plugin architectures with JPMS is the thing that said, now is the time to jump. And I believe that Gunnar will do a much better job explaining about this.
I mean, so about what I mentioned in the beginning, so layers really allow us this kind of dynamism, right? And we can add and remove functionality to an application at runtime. Of course, we should wonder, or we should spend some time thinking, should we really do this? Now, I think on the server side, there is a very clear trend towards immutable images, right? You put everything into Linux container images, and you don't really want to already need this kind of plugin functionality. If you want to add functionality to your application, you would just create a new version of this container image. You would have things like load balancers in front, you know, so you could roll out those versions without any kind of noticeable downtime. So I suppose for the server side, all this wouldn't be so interesting. But then things look a bit different if you think about your rich client, like your IDE, your editor, or your browser. Well, if you install things like a new plugin there, you don't want to restart this, right? So you want to keep this running. You don't want to have this interruption. Or if you think about IoT scenarios, where maybe you have some sort of IoT program which receives some sorts of sensor measurements, you don't necessarily would like this to be interrupted just for an update, let's say, of some code there. And there, this dynamic plugin functionality comes in really handy. And Layrry makes it quite easy to use this, and there's essentially just a single interface in the Layrry platform there, and this is called the plugin lifecycle listener. And in this lifecycle listener, you essentially just have two methods which notify you about the addition of a plugin, which really is just a layer of modules, and if a plugin layer gets removed, and then you can react to that. And currently, this happens by Layrry watching a directory in the file system, as we will see in the demo. So you add a plugin by copying the jars to this plugin directory. But of course, we also could think about, you know, making this programmatically or fetching plugins from remote, all kinds of things. This could be an option. So what do you do now in this plugin lifecycle listener? Really, the idea is you use, again, what's already there in the JDK. So you try to reuse as much as possible from the JDK. And this is the service loader, which already exists, I believe, since Java 6 or even you know, internally before then. And what you typically do in such a plugin lifecycle listener is once a layer gets added, you look for service implementations within this layer that got added. And so you would define your own service contracts, which are the extension points of your application. And then if this layer gets added, you would look for implementations of those services, and then you would register them, you would invoke them, whatever your application needs to do. But really, that's the way how this would work. And to make it more tangible, Andres has a fantastic demo based on JavaFX, which shows this a bit in action.
Right, so I'm gonna share the screen right now. And so we're gonna switch. Hopefully nothing bad happens. So, okay, I'm going to now go into the terminal and show you the layers files that we have here. This is pretty much the same layer that we saw in the slides. And you can see that it has these placeholders for values. So the first layer is the JavaFX layer that contains all the artifacts required to bootstrap JavaFX. Then we have the application modules themselves. So we have something like module, core, and application. Here, the Layrry platform is the module that contains the plugin lifecycle listener. So when you want to have a dynamic plugins, you have to add it, and then there's additional dependency. And finally, there is this layers plugins layer that has a reference to a directory called plugins. It could be anything you want to, just decide to go plugins. And this is the place where if we place additional artifacts like the jars that contains Layrry-enabled plugins, then our application will kickstart. Now, I'm going to use a local version of jbang to start Layrry. And notice that I'm passing that TOML configuration file and the versions properties. And in just a second, the application will pop up in my other screen. So now I move it over here on the top. You can see it. It's empty right now. And the application will keep running And I do have a set of prepared plugins here. This is the structure that I'm going to copy to the plugins directory that Layer is listening to right now. So if I copy all of them like this, let's say from staging into plugins prepare, while the application keeps running into plugins, and it's just going to put a start here, you will see in just a second, boom, we got 3 additional visual elements appearing in our application. And if I remove one of those from the plugins directory, let's say we're going to remove the one in the middle, that I believe is Gauge, like this, and it goes away. And just like that, if I want to, I can copy all over again. And the way that the application is built, it does not duplicate an existing tile, and there it goes. And this is just possible thanks to the dynamic loading of Layrry. Now, you may be thinking, well, we're adding classes at runtime, we're loading classes, and we are unloading classes. And this is a typical scenario for having memory leaks. As it turns out, there was a memory leak in this and an early version of this application, but we were able to detect this problem thanks to one of the benefits that Layrry has, which is it exposes events for JFR. And this is an investigation that Gunnar did with additional tools, and I think that now Gunnar will be a good moment for you to explain what happened.
Right, so just to give some context, JFR is the Java flag recorder, and it's open source, I believe, since 11. And it's a really fantastic tool to get insight to all kinds of metrics of the JVM, like what allocation rate is happening and processor usage and all those kinds of metrics. But also you can add custom events, which you can then track via the flight recorder and the Java Mission Control client tool. And now, as Andres was mentioning, well, if a plugin layer gets removed, well, ideally all its classes and also its class loader should be subject to the garbage collection. So there's no way or no API where you could explicitly unload or remove a class. Instead, you just need to make sure you don't keep any references anymore. And once that's the case, then the garbage collection will just get rid of all the classes and also this class loader, which this is about. So in our case, if we remove a plugin layer like the Gauge tile, then really this should be subject to the garbage collection. And now this, as Andres mentioned, there's a few situations where we have what's called a class loader leak. So there's still a reference dangling, and there's a few potential causes for that. One just would be you have a reference in one of a remaining layer. So in the JavaFX example, there's like a base layer which essentially keeps track of all the tile plugins, and it has like a tile registry. And now, if you were, if you forgot to remove a tile from this registry once the plugin gets removed, well, then you would already have this kind of class loader leak. Or maybe such a tile starts actually a thread, and this was the case for us, which we didn't know initially. It starts a thread to produce this random data, and if you forget to stop the thread once this plugin layer gets removed, again, you would keep this class loader leak. And there's a few other situations, but really, if you take care of everything, this class should be unloaded. And now, if you are using the default garbage collector, which is G1 since Java 9, there's actually this very interesting option of the periodic garbage collection. So this means before that, and I think this was added in Java 12, before that, actually, classes would only be unloaded if there was like a full GC happening. Whereas now, if you specify this option, it will run in parallel, and also in regular intervals, it would then discard any classes which well, are not used anymore. This is, of course, very nice. And also it works with the concurrent class loaders like, garbage collections like Shenandoah or GC. All right, so let's take a look into how we can actually go about and look into those things. And as I mentioned in Flight Recorder, you have the way of ability to produce custom events. And this is what Layrry is doing. So it adds a event whenever a plugin layer gets added or gets removed. So this is just very interesting to look into. So you get some understanding, okay, now at this point in time, a particular layer was added and it contained a specific set of modules. or now this layer got removed, and all those modules should also be removed. So this would be your starting point. By the way, you can keep such a recording essentially running on a permanent or continuous basis, and then you just can dump like the last few minutes from your running application and load this into mission control as we see it here. So that would be the starting point. And then you actually can correlate this with the class unloading events. So JFR also can capture events. You need to enable this when a class gets unloaded. So the expectation would be, if you see in your JFR recording, you see those events about a plugin layer being removed, at some point thereafter, you also would expect those unloaded class events. So here in this case, this is working as it should. I see the clock tile plugin got removed, this class, in this case, this Sparkline tile plugin class, and so on. So I see those events. But now it would be suspicious if I were to observe events about the removal of a plugin layer, but I would not see any class unloading events. So in this case, this would be the hint for me. There might actually be a class loader leak here, and this is something I should look into. And now, of course, the question is, how can I go about that and find out, well, what are my leaking classes and where are they leaking? And this is where another tool comes in, and this is called the Eclipse Memory Analyzer tool, which is really very handy. And this really makes it very easy actually to understand and find out about the situation. And there's essentially a view which is called duplicate classes, and this would be the hint for us to where we have to look. Because if a class gets loaded by multiple class loaders, or just multiple times really, then it's fast, it's the indication apparently something got wrong, because otherwise this class would have been unloaded already correctly, and we only ever should see each class being loaded once. If you see it being loaded multiple times, that's not right. And this is what I can quite easily see in this duplicate classes view of the Eclipse Memory Analyzer. So here it tells me, okay, the clock tile plugin class, this has been loaded by those 3 loader classes. And really 2 of them should already have been discarded, so something is wrong, right? Now what you can do now is you just right click there and you say, show me the path to what's called the GC root. And then it will actually tell you the path of the reference which holds this plugin class. So let's go to the next one. And this is how this would look like. And actually, in this case, I just modified the plugin registry. So it's not NRS poor coding which was causing this. This was for the purposes of demonstration here. So here I have a member which is called leaking plugins in my plugin registry. So this is in this base layer I was mentioning. And now what happened is, well, in my plugin lifecycle listener, when I was adding this layer, I was adding all the plugins to this leaking plugins set, but then I didn't remove it when a plugin got actually removed. And so all those references were being kept in this leaking plugins collection, and this is how you would have produced this kind of class loader leak. And now, of course, the call to action would be to go to this plugin registry class and, well, in this case, just remove my fake leaking plugins collection, or update the code so then when a plugin gets removed, also the classes get removed from this set. So this is how you could go about those things. In our case, it was a bit more difficult. It was actually a thread which was still running, but you also can quite easily see this in this view, and you would find out about it quite easily.
Mm-hmm. So with this, we're pretty much at the end of the session. We hope that you have had a good impression of what Layrry can do for you in order to get acquainted with the different options that the JPMS allows you. The source code for Layrry is available on the first link. The source code for the JavaFX example, the full example, is available on the second link. And as time passes by, we will continue to add other examples. There are actually a couple of integration test cases in Layrry that show you how you can use dynamic plugins with Vertex. In case that is something that interests you, we will eventually move that to Layrry examples and a few other things as well. So that typical use cases where you want to have just static setup layers or with dynamic layers and a few other options, you will find them in examples.
And we should,
Gunnar?
I think we didn't mention this yet. It's all open source. It's Apache licensed, so it's free to use, of course. And there's no limitations to that. And everybody, of course, is also very much invited to contribute and join the effort on that one.
Yes, definitely. Please do so. Gunnar has posted his thoughts about Layrry. We have 3 series, and if you are more interested to know more about the class unloading issues and the memory leak that we found in the problem in this particular application, the 3rd blog post goes in deep detail on how he used these tools and the investigations that we follow. And with that,
you're also going to write another post, right, about the JavaFX example?
Yes, exactly. Because of course, Layrry is not specific for JavaFX, but it makes it for a very compelling, a very interesting example to show. And yes, the blog post will be coming very soon. So with this, we'll thank you very much. And if you like the talk, please rate it on the official JFall app. And we're more than happy to take your questions during the time that we have with you at JFall at any other time. Just feel free to ping us online and go to Layrry, start the project if you want to, and give us your feedback if you can. We will really appreciate it. We love the open source, and that's what we're doing this thing.
Absolutely. Thank you so much for being here, and let's discuss in the chat.
Thank you, everybody.
So with that, it's time for our Q&A section. So I'd invite Andres, Raid, and Gunnar to turn on their webcam and microphone too. And I believe you wanted to switch it around for the first question, right?
Yes. So the video cut short a little bit, but it was pretty much on the links for everything that we see in the presentation. I think we will be make available the slides and all the links for everybody to have a look at. Yes.
Right, and as Tim was saying, so we did prepare a poll because we are curious which Java version you are using currently. So you can go to the content library. So that's those 3 dots on the left-hand side. Click there, and then I think the lowest, yeah, the lower one, that's content library. And then you have this polls option, so you can choose which versions you are using, and you can select multiple ones. So it's like if you are using more than one in production, you can click all those, and then later on we can take a look at what you're running in production.
I think you have to open the poll, Gunnar.
It's open. It says I can only close it now.
I can't see it.
You can't see it. No. And I can try close, okay. But let me see. Reopen. Ah, damn it.
Well, what Gunnar is going through that, I'm going to answer the one question from Michelle and Tom. They're pretty much asking what sort of IDE or build tool integration. Yeah, there's a poll. So what sort of build tool integration can we expect from Layrry? So at this point, we don't have any yet. We are waiting for feedback from users, from other players, for other use cases to see where these things could go. Because certainly right now, without Layrry, if you want to build a modular application, whether it's with Maven or Gradle, you have to define the dependencies in the build file, define the model descriptor in modelinfo.java, and if you build it with Layrry, then you also have to specify the layers. So there's pretty much the same information found in 3 different source files. Is there a way that we can combine things together to remove the duplication? Not yet. We are still trying to figure out. One of the options that we found is to give you the ability to have the placeholders with the additional properties files. So at the very least, then that way, with Maven or Gradle, you can automatically generate the properties files based on the version numbers that you already have configured in both Maven and Gradle. One of the Layrry examples, the JavaFX application, if you browse to the repository, you'll find that project is built with Maven and with Gradle, and it showcases how you can structure your build in order to generate the versions properties file.
All right, sorry, I got disconnected for a bit, so I'm not sure where we stand, but Andres, take it away. Sorry about it.
Right.
Did we have already, would it be possible to build the layers from a POM and its transitive dependencies?
Yeah, that's the question from Tom, is that there is this duplication. If I define my dependency, the POM, then if I look back into the layers YAML file TOML, then I see almost the same information. Technically, yes, you have some of that information, but what is missing in the POM file is the separation between the layers. You will see in the POM file the config for JavaFX and all your projects, but how would you tell Maven or a Layrry plugin, if you will, that the first set of dependencies will go into layer 1, and then the next set of dependencies, whichever it may be, go into layer 2, and 1 and 2 have some sort of parent-child relationship. So for this reason, we don't offer yet any IDE integration or any build tool integration, because we're still trying to figure out how that could look like.
But I mean, what Tom makes an interesting suggestion, right? If I understand it correctly, the idea would be to create a layer for each direct dependency, and then, you know, take its transitive dependencies and put all those, like one dependency and then its own dependencies into its own layer. This is something you could derive from a POM. So we would have to think about the implications, what that exactly means in terms of, you know, you share classes between layers and so on. But that could be an option I could see, yeah.
Yeah, the option of having a POM, a project per layer, is also a good idea.
Yeah. So I mean, definitely, Tom, if you got more you know, thoughts around it, definitely come to the GitHub project, and we should discuss it in more detail, I think, in the issue there. And we, I mean, we're very, very open for improving the situation there.
Yes, we welcome all questions, contributions, and feedback.
So I saw a question earlier about the name, Layrry.
Right. Yeah. So it really was a play on layers. I mean, I wanted to have something which didn't really exist yet, and it is like nicely Google-able. I don't know how you say it. And then, you know, at some point I came up with. I mean, I wanted to do layman, but this all was taken. So I came up with Layrry, and I mean, I'm a big fan of Leisure Suit Larry, as I hinted in the answer. So, you know, it also is a nice reference to that little fellow.
Right, and there was also a comparison to OSGI. Could you go into that?
Yeah, I mean, so on OSGI, really, I would say it's a very completely, it's a completely different level of complexity in what it aspires to do, right? So Layrry aims at a much lesser level, I would say. Really, for Layrry, the focus is about making, you know, layers usable, give you this kind of isolation so you can have this multi-version problem solved. It deals with provisioning modules and jars by downloading them via the Maven dependencies, and it has the simple notion of plugins and removing that, and adding and removing them. But really, OSGI does much, much more beyond that, right? And really, I think if you need what's there in OSGI, you should go for it. I mean, I have nothing against it. I think it's a very different scope, really. But at the same time, we also hope to make this kind of problem space a bit more accessible, right? So let's say in OSGI, you are often stuck because you need to have the proper module metadata. Each module is coming with its own class loader, so this is very strongly isolated. And Layrry tries to lower the bar and give you some of the advantages, but at a more accessible level, I would say.
So Tom says, isn't that 90% of what OSGI projects use for OSGI features? Perhaps. I'm not an OSGI developer, and I touched it many years ago and haven't come back for reasons. And if that is the case, then JPMS and Layrry will certainly give you the features that you're expecting. And there's another thing that will come in the future. We still have to figure out how it's going to go. We will allow you to configure layers in a remote location, not just locally.
Right. So.
Okay, so our time is running out. Do you want to come back to your poll, or?
Yeah, let's take a quick look there. Let's just see what people say. All right, so I need to close it. Can people see now the results? I'm not sure whether everybody can see, but I can read it out. So like 3% is 7 or less, like nobody. 44 on 8, so that's actually the same 47 even is on 11. So more people on 11 than on 8. Nobody on those like 1% on those intermediary unmaintained versions like 9, 10, 12, 13, 14, and nobody, literally nobody on 15. So the majority on 11, which is cool. So you're in a good position to actually take advantage of what we've shown here today. It's very insightful.
Okay, great. So thank you very much, Gunnar and Andres, for your very interesting talk on Layrry. I'm sure I will sure look into it. And thank you for our audience for attending this session, and enjoy the rest of your JFall.
Have a great JFall. Thank you so much.
Thank you, everybody.